All right, guys, I wanted to go over the solutions to week 2, lesson 2, the trig word problems, the document, and the PowerPoint presentation. Uh, Got to apologize on Mr. Bliss's behalf. This first question he put in here, you won't be able to solve yet. It's going to be something you'll be learning with week 3, lesson 1. So we can skip this. I did not count this when I was looking through them. Looking at the second one, we have a kite with 20 feet of string extended. An angle of elevation is 67 degrees. How far off the ground is the kite if you hold the spool 5 feet off the ground? So my angle of elevation is right here. That is 67 degrees. The kite string is 20 feet. And I want to know how far off the ground it is. So I have the opposite side and the hypotenuse, and the ratio that compares the opposite to hypotenuse is sine. So I have the sine of 67 degrees is equal to opposite over hypotenuse. So to solve for x, I must multiply both sides by 20. So I get 20 times the sine of 67. And then you're going to go to your table or your calculator to plug that in. And I get 18.41 feet. For the height off the ground, I then have to keep in mind this little part where I'm already 5 feet off the ground. So I'm going to add an additional 5 feet to get a final total of 23.41 feet. And that's how far the kite is off the ground. Moving on to the next one. Got a 500 centimeter ladder leaning against the building. The angle between the ground and the ladder is 57. So this angle is 57. The ladder is 500 centimeters. How far from the wall is the bottom of the ladder? So I want this part. So I have the adjacent side and the hypotenuse in relation to the angle. And that would be a cosine. So the cosine of 57 equals the adjacent side, which I don't know, over 500. So to get x by itself, I'm going to multiply both sides by 500. So I have 500 times the cosine of 57. That will equal out the distance away from the wall. And again, you can use your table or a calculator. 500 times the cosine of 57 is equal to 272.3 centimeters. Moving on to our third of 4. An observation tower is 75 meters high. So the height of this tower is 75. The support wire attached to the tower 20 meters from the top if the support wire and the ground form an angle of 46 degrees. What is the length of the support wire? So the whole tower is 70, but where this attaches to the bottom, because it's 20 meters from the top, is actually going to be a height of 55. So even the whole tower is 75, the height I'm looking at in my right triangle is going to be 55. And I want to know the length of the wire. I have the opposite sides and the hypotenuse, and I'm looking for the hypotenuse. So that ratio is sine. So the sine of 46 equals the opposite side over the hypotenuse. So I got to get the x out of the denominator. We're going to multiply both sides by x. When I do that, it's going to cross out here. And to get x by itself, I'm going to divide both sides by the sine of 46. So that x equals 55 divided by the sine of 46. So I put that into my calculator. And I would find out that the distance or the length of the support wire is 76.5 meters. So notice when I had an unknown in the denominator, I ended up dividing by the sine of the angle, as opposed to what we've done in the past too, which was multiplying, because the unknown was in the numerator. And last one, the shuttle. Television cameras at ground level filming liftoff at a point 750 meters from the launch pad. Camera's angle of elevation is 32 degrees. At a certain time, how high is the shuttle? So I don't know this. So the opposite and adjacent are where I have information. So that would be the tangent ratio. So the tangent of 32 equals the opposite side, which is my unknown, over that 750 meters. I'll have to multiply both sides by 750. So 750 times the tangent of 32 is 468.7 meters. And that would be the height of the shuttle at the given time. So most of you did pretty well with getting these relationships and the ratios set up. So let's take a look at the PowerPoint. Okay, so over here at the PowerPoint, our first was just writing out the ratios. So for the large triangle, the sine is opposite over hypotenuse based on angle A. So the opposite is 8, the hypotenuse is 17, the adjacent is 15, the hypotenuse is 17, the opposite is 8, the adjacent is 15. So those would be my ratios. For the small triangle, again, based on angle A, I have 4 over 8.5. I have 7.5 over 8.5. I have 4 over 7.5. So when we're asked to compare, I'm going to multiply a small triangle by 2 over 2 to get rid of these decimals. So that would give me 8 over 17, with 15 over 17. Will give me 8 over 15. Well, hopefully you'll notice that the ratios are in fact the same, just a scale factor of 2. So we have similar triangles. And if I were to create them in all decimal form, all the decimals would be equivalent. But here I'm trying to find the height of the tree when I am 45 feet away from the tree at an angle of elevation of 59 degrees. So I'm looking for the opposite side. I have the adjacent side. That means I'm going to need to use tangent. So tangent of 59 is equivalent to h over 45. Multiply both sides by 45. Again, calculator, 45 times the tangent of 59 gives me 74.9 feet as the height of the tree. So once we figured out the correct ratio, it's pretty easy to solve. It's figuring out the ratio that's the difficult part of trigonometry. So I'm skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance you ski down the mountain to the nearest foot. So angle of depression is this angle here. So if this angle is 21, alternate interior angles say this angle is also 21. Or because this is a right angle, the inside of this up here would be 69 degrees. The height, the altitude is 1,200. And I want to know how far I've gone, how the distance to ski down the mountain in the nearest foot. So I have a couple options here. If I want to use the 21 degrees at the bottom, I have the opposite in hypotenuse, so I would use the sine. And when I solve for x, I'm going to get x equal to 1,200 divided by the sine of 21. Which is 3,349 feet. If I wanted to use the 69-degree angle, I'm now using cosine. So I have the adjacent side and the hypotenuse. So x would be 1,200 divided by the cosine of 69. And what you'll find out is that you get the exact same answer regardless of which way you go. The most common mistake with angle of depression and angle of elevation is that people think this angle up here is the angle of depression. It's not. It's off of the horizontal. And it's equal to the angle of elevation. Just looking up. So the last problem we had was using our surveying tools to find the distance from the house on a shore to the house on an island. So where we're surveying from at a 42-degree angle to the house on the islands and 40 meters away from the house on the shore, we want to find that distance across. So again, I have opposite and adjacent sides in regards to this 42-degree angle. So that would mean I'm going to use tangent. Solve for the distance. I'm going to multiply both sides by 40. And 40 times the tangent of 42 is 36. Meters. So those are the solutions to the two word problems. There's a document also in this tab with the solutions to the problems from lesson 1. If you have any questions, please reach out to myself via email We can set up a video chat or anything to go through to make sure that you're on track, as we will be preparing for an assessment coming up.